I know they're three-dimensional, but they're going to sit like this, something like that. Whereas if this is one is a scalar multiple, so all these you can see have been doubled, then they're actually just plane 1 is equal to plane 2. It's just they're on top, they're there. They are the same one.
Isn't that one bigger?
No. Yeah, they're infinite in all directions. Okay. Right, so we know the difference between parallel and coincident. Now, when 3 planes interact, of course, we can add another one. So let's go 3x plus 3y plus 3z is equal to 5. What do we know about this one? This is plane 1, plane 2, plane 3. It's parallel to both of them, but it's not. It's like it's down here, isn't it? It's a plane 3. It's parallel to these two, but it's not on top of it. It's in a different position. It's
because plane 1 and 2 are coincident, and plane 3 is just parallel.
Yeah. But if I multiply this number by 3, 78, then all of a sudden it's they're all 3 are coincident. Okay, so that's our starting point. We know the difference between coincident, we know the difference between parallel and coincident, and we know kind of how that would look like if we were given the equations. So when we're given 3 planes, which is going to happen in a minute, we have to be able to look at the equations straight off and figure out are any of them parallel or coincident before we start going to try and solve anything or do anything with them. It's usually a good starting point. So I'm going to go to the question and come back. I just want to freeze because I have diagrams on the next 2 pages. We're going to do these questions in a second. So we're looking at a couple of linear equations. I'm going to put them up here because I'm going to do them in a second. 3 minus z. I want you to pick out are any of there are 2 different questions. Are any of these parallel? Oh no, 7. Or coincident, or can you say anything about them? Okay, so that's question 1. Question 2, then another set.
I don't think there's any relationship.
I don't think there's parallel or coincident.
Wait, no, x plus y minus z and 3x, 3y. That's, oh,
B
no,
has-
that's not how that works. That's not how that works.
Wait,
Sure.
wait.
Yeah, there's different questions.
It's a minus y and a minus z.
Oh, yeah. Talk about that one.
Yeah.
Minus 3y
I thought it was talking about
plus 3z is equal to 8. So we have these 2 questions. All right. Not looking likely. They're pretty similar.
They're all going to have a single midpoint.
But they're not going to be parallel or coincident, I don't think.
So there's only one point where...
Okay. What's that mean?
Like if they're not,
It means that they're like going like this or like
They're
this.
skew or
like
something.
Okay.
There's no such thing as
There's
skew because
8 different ways
like
that
in 3D, it's not possible to have
3
skew.
planes can meet. Now we already discussed these. If all 3 are coincident, you should notice that straight away. X plus y plus z is equal to 2. 2x plus 2y plus 2z is equal to 4. And 3x, this is a very simple example, plus 3z is equal to 6. There'll be 3 coincidental, plane 1, plane 2, and plane 3. So that's 1. They're all coincident. And that's what that would look like if they're all coincident. Each one would be a scalar multiple of the other. 2 are coincident, and then 1 kind of goes at a different angle, or different, angle as well to it. What would that look like? So 2. Yeah, I know. I just want to leave this up when we start to do them.
Which means that there's a whole
2 coincidence and 1 intersects.
It means there's a whole line where they intersect, right?
Yeah, there's a whole line answer when they intersect, yeah. But it would look like something like, okay, you can see that 2 of these are coincidence, and then the other one's just different. The other one's just a different, and that's how we know, oh, these 2 are coincident, and then there's another one that's different. The other one we looked at then is 2 coincident, 1 parallel. No, you don't.
Can I take a photo?
Yeah.
I'll just wait until you
Yeah. So 2 coincident, one parallel. So that's where, okay, so these 2 are coincident. We need another one that's parallel. 3x plus 3y plus 3z, but it's not a scalar multiple.
It's like when you have intersecting angles.
Wait, intersect is 12.
Okay, next one. 2 parallel, 1 intersection.
Then it's not possible for a plane to be skewed in a 3D space because it basically spreads throughout the whole
Yeah,
space.
continues
They will
forever, so
eventually touch
at some stage. Yeah.
Your variable was
So 2 parallel, if I change this to 7, for example, these 2 are parallel, plane 1 and plane 2 are parallel, and this one has a different, just a different relationship.
There's 2 lines that intersect, but like there's no line where no point where they all intersect.
Yeah, so that's that one. 2 parallel, so these 2 are parallel, and then this one's intersecting both of them.
Is this the last bit?
This is the last bit.
Yeah, it's kind of hard to go further from here except for 4D.
Yeah. Yes.
Oh, 3 planes.
What's number 3 again?
Okay. The 5th one then is all parallel. All 3 parallel, of course. That would be then, if I look at it, 3x plus 3y plus 3z. So that's parallel, but that equals not the same.
This has to be the most boring one. There's nothing going on here.
Yeah, nothing really to show.
Nothing special except for the fact that they're all like
Yeah.
a width somewhere in there.
I mean,
So 6 and 7 are the most likely to come up. 6 and 7 all meet at one point.
That one's pretty easy. It's when there's no relationship between all 3 of them.
Sorry?
Is that the easiest?
It's easiest to find, yeah.
Yeah.
If they all meet at one point, that means they're all different equations. I'll stop using these. It would look something like one of these 2. They're all different. We notice no parallel, no coincidence. Okay, we have to go do something to find out if they meet at a point.
And value of x, y, and z being all of them equal.
You'll get 3, Abby. You'll get 3 answers. You get 3 exact answers for x, y, and z. When you solve for this, it'll just be 1 answer for x, 1 answer for y, 1 answer for z.
Are we gonna do that?
Yes, we'll do that in a second. One of these will have that. And 7, they meet at a line. So instead of meeting at a line, or instead of meeting at a point where they're all going off in different directions, really, they meet at the common line here, which creates that sort of a fan-looking thing. They all meet along a line. Yeah, so when we get to do row reduction, these 2 are. When we get to do row reduction, these 2 are going to look. So we're going to solve these using matrices, row reduction matrices.
Would it be easier to substitute?
You could try.
No.
I think it's easier row reduction. We're going to do them in a second. When they all meet, this will be our usual 1, 0, 1, 0, 0, 1. And all these are just numbers. And you'll get an answer for x, y, and z. That's what that would look like.
What does 7 look like?
The other one then, 7, we get 1, 0, 1, 0, 0, 0, 0.
Wait, why are we back in system to
Oh, 0, 0, 0. Interesting.
Why are we doing
So there's no, there's not one solution. So what we have to do is use z is equal to t at this stage.
We're not equal.
To get, because t will get us parametric equations along. We'll get parametric equations, so we get a bunch of answers for x will look something like x is equal to 1 plus t, y will equal to 2 minus 3t, and z is t or something like that, and then that's an equation of a that's what an equation of a line looks like, isn't it? In vector form, position and direction vector and some parameter t. Yeah. Yeah. That's what we get from this one. Now maybe you're not there yet. This is confusing and does not come up very often. And we'll look at one specific example of this either tomorrow or Monday. We won't look at this today. The line of any line of intersection is parallel to the third plane.
In theory, it's not that confusing, but like it's a lot of process.
Yeah.
Yeah, I guess.
Okay, and I have an example. So the line of intersection is parallel to the third plane. So they don't just meet at one particular line. They meet at, but there is a relationship between them. And we look at that one in an example tomorrow.
I take it at this point, yeah.
Or maybe we do a practice test tomorrow. I can't remember which. Okay. So, some of these, when we do row reduction, are just going to give nonsense answers, as in there won't be a solution. So we're going to see that a lot. We're going to see not solutions a lot, especially for these first 5. Because as soon as 2 are parallel, they're never going to meet. So there's never going to be a solution. So there's going to be some nonsense answers. And then we won't be able to find, like in number 4, we don't have enough information to find both of these answers.
We don't?
We won't have, no.
Oh.
No. So that's why these 2 come up the most, because this is the ones that we can find the answers. They're pretty straightforward to do because it's just row
I
reduction.
mean, technically the easiest would be 1.
Yeah, as long as you recognize that when you see it and don't try and do row reduction. But you'll figure it out very quickly.
You can do multiplication and division.
You'll figure it out pretty quickly that you're wrong
When it
doing
gets
row
0,
reduction.
0, 0,
Yeah.
0, 0, 0, 0, 0.
Yes. Okay. So let's do. I'm going to just remember how to do row reduction, both of these at the same time, before I interpret the answers. So we'll start off with both how we write them as matrices: 1, 3, minus 1, 15, 2, 1, 1, 7, 1, minus 1, minus 2, 0. To draw the line here, what these are the coefficients. The line here is the equal sign.
What's the coefficient?
I've put the coefficients. I've left out x, y, and z. And
That's
just
what a coefficient is?
the coefficient is a number in front of x, y. Yeah.
No, I
You
understand.
could explain it that way.
You're in year 13.
Okay. I'm going to do the same for this one, but a little trick here. You do not have to do them in the order that they have them. What would be useful to do here?
0.
Put this one as the first one. Put this. Why do I want to do the second one as the first line? Because it already starts with 1, and the first thing I have to do at row reduction is bring this line down to 1. So I'm actually going to swap these 2 when I write it in. 2, minus 1, 1, and 5, 3, 3, 3, and 8. Okay, so now that's my 2. I did swap these 2 around just so I start with 1.
Oh, we're doing 2 questions at once?
I'll just set them up at once, yeah. I'll finish this one, then I'll finish that one.
I'm
Then.
gonna finish question 1 first.
Yeah, we'll do, yeah.
So
But I'm just,
the order of which you put them in doesn't matter. at
does
all.
not matter.
It just makes
No.
do whatever.
You should get the same answer no matter what.
As long as you
Okay, so let's remember how to do row reduction. What's my next number to get rid of
the 2
in this one? I want to get rid of the 2, and then I want to get rid of the 1. I'm going to, and then I'll move on. I'll rewrite again, and I'll do this column first. Yep. So 1, 3, minus 1, and 15 is okay.
2 times row 1.
Okay, very good. So row 2, take away twice row 1, will leave me with a 0 in this position. So row 2 is 2, take away twice that is 0. This, take away twice this is negative 5. This, take away twice this is 3. This, take away twice this is minus 23. I have to make a 0 here as well, so maybe I use, I'm going to use row 1. Row 3, take away row 1.
Row 2, what does that say? Row 2 minus 2R1?
Yeah, twice row 1. Okay, I'm going to subtract these two because I know 1. Take away 1 is 0. This, take away this is negative 4. This, take away this is negative 1. And this, take away this is negative 15. All right? So
We need 1 now.
I need 1 in this position and 0 in this position.
Divide by -5.
Yes.
And then you subtract.
Okay, so the first thing, if I just have one number to reduce to 1, and sometimes you have to do it with this number as well, I'm just going to divide by whatever makes this 1, or we say multiply by negative 1/5, row 2. Negative 1/5 is going to, negative 1/5 of that is 1. So I get 0 because that's times negative 1/5. That is 1. I knew that was going to happen. That's going to be negative 3/5 at positive 23 over 5. Not particularly nice, but yeah. The next one then, I got to reduce this to 0. So
Minus a third of
Whew.
row 2, right?
you can do it a couple of ways. I'm probably going to go 5 times row 3, take away 4 times row 2. It's because I'm going to be left with 0 still if I do that. Okay, 0 is what we wanted anyway, but 5 times this row, take away 4 times this row, leaves a 0. So I did 5 and 4 because these were opposites, and I make it 0. 5 minus 5, take away
Minus 12.
minus 12.
So
So minus 17, yes.
Do we want a 1?
Wait, take
We do
away
want a
minus
1.
12?
We'll get on the last row.
Does that say take away minus 5, take away minus 12? Or minus 5, take away 12?
This 5 times row 3, take away 4 times row 2. So 5 times this, take away 4 times that. So that's take away 12. 5 minus 5, take away 12. 5 times this is 5 times that is going to be negative 75 plus 4 times 23, 80, 92. 92 minus 75, 17. Yeah. And, wow, I think so. All right, final stage, divide by 17. Now, you can, if you want to skip, you can not rewrite this, but I'll rewrite it anyway. 0, 1, negative 3/5, 23 over 5, and 0, 0. I'm dividing by, or I'm multiplying by minus 1 over 17. 1, negative 1.
Yeah.
Okay, we're there. We got it. So you need to be able to do that. Very common paper 1 skill. Z is negative 1. What's this telling us straight away? Which one of my 1 to 8 have we got here? Over here. Which one have we got, do you think?
I would imagine it's 6.
All meet at a point.
6, yeah. They all meet at a point. We've got a unique solution. Z is equal to negative 1. We've finished this. So Z is equal to negative 1. I'll do it here. Z is equal to negative 1. We know that because that's in the Z position, negative 1. Once I know Z is negative 1, I also have this formula, which is Y minus 3/5 times Z, which is negative 1, is 23 over 5. So Y is 23 over 5 plus 3/5, which is 26 over 5, is it?
What?
You would have to.
Oh, minus, sorry, 20 over 5, which is just 4. Oh, yes. Yeah, you got there faster than I did. Okay, Z is minus 1. Okay, we've got X plus 3 times Y, which is 4. So I'm using this line. Minus 1 times minus 1, so Z is here, is equal to 15. So I got 12. X is 12 plus 1 is 13. 13 take away is 2. What does that say? Well, that says that these 3 planes meet at one exact point. There's one exact solution for them all. What is that solution? It's the point 2, 4, minus 1. It's this point. That's my answer. It's number 6. It meets at a point. Okay? So that's kind of the one you want because it's just a very nice, it worked out, and we have a solution that we can work with. Okay, so we'll pick up question 2 now. We get continue with row reduction. So that's question 1 done. Let's continue with this one. I foresee some problems ahead because I've done the question, but
Well, that's not pleasant.
but what problems is more towards the end when we try and interpret the solution. Doing it step by step. We have a 1 here, so next we got to get rid of this 2 and this 3, so we'll do that. 1, 1, minus 1, 2 is the first line rewritten. We can do row 2, take away twice row 1. 2, take away twice. Oh yeah, that's going to lead to 0. This, take away twice this is negative 3. This, take away twice this.
Is plus 2 is 3.
Yes, 3. This, take away twice this. Very good. No. Am I wrong? Oh, let me check what I did earlier. Yes. No, that's right. Yeah. Okay.
Now you need to get rid of the
Row 3, take away 3 times row 1. So 3 take away, we'll turn this into a 0 as well. We happy with that?
Yes.
So I want a 0, yeah.
It's going to be 0,
0, uh-oh.
6.
Uh-oh. 3 take...
Wait, isn't that what?
6? 6, yeah. We okay with that?
Isn't R3 meant to
Two.
be negative 3 in the middle?
2.
Because it's negative 3y?
2.
Well,
It's negative.
no, R3 is 3 minus 3R1, which is 3.
Negative 3y.
Which one are you looking at here?
Look at the equation.
Oh.
Oh, thank you.
Oh, wow.
Oh, wow.
Negative 6.
So we get negative 6?
Negative 6.
You know, I'm not sure if that makes it any better, but
no,
it's definitely more correct.
You were right, it definitely is more correct. Okay, I didn't make that mistake when I did it, so we're all good. Row 3, 8, take away 3 times. Yeah, 2, yeah. Oh, all right.
Can we not? Oh, wait, never mind.
What do we do now?
Ooh, I foresee problems.
Is that a problem?
Do we
Okay.
turn this 3
Let's just stick with...
1?
That's right, isn't it? Yeah, that's what I had earlier. Okay. Well, maybe there's no problem. We want this to be 1, yeah? So we divide by... Okay, so 1, 1, minus 1, 2, rewritten. This one, I'm going to say negative 1/3 of row 2. And that's going to get me to 1. That's sweet. 1, negative 1, and negative 1/3.
There's no solution.
Okay, so I need a 0 here.
Just do. If you do R3 minus R3 plus 2 R2. Yeah.
R3.
Wrong.
What?
Minus 2
No.
Yeah.
R3 plus. Wait.
Minus
Oh, sorry.
6
Yeah. R3 minus 2 R2.
Okay, so R3 minus 2 R2 will give me a 0.
0, 0. 2
Mm.
minus.
Yes, we do end up with
Something.
0, 0.
2
Row,
minus 2 is 0. There's all zeros on the bottom.
all zeros at the bottom.
That's just hit the grading, guys.
That's number 7.
And then we assume that Z equals T.
Wait, is it 7?
Yeah.
How do you guys know?
Because he said so.
Oh, yeah, okay, well, why is it 7? That's obviously
Why
the question.
Is it 7?
Because you literally said.
It's because
I did say it, but...
It's because the Z plane is the same for all of them, right?
Okay, yeah. So it's not a nonsense answer. It's not 0 times something is equal to 6, which would be kind of a it's 0 times something is equal to 0, which is correct.
Normally, that's not
Yes, but that doesn't mean we know any answers for it.
It assumes that Z could be any number.
Yeah, basically, yeah.
And that's why it's a line, because there's like a whole plane.
We got
Any number along that line.
Yes. So we assume Z to be T, which will help us form out the parametric equations of said line. So at this stage we go, okay, if we get this line, we go Z is equal to T, and we start on our merry way of...
So Y minus.
So we use this next line. Z is equal to T is our starting... Oh, let's write it. Z is equal to T from this line. So we want to create the equation of the line, because we don't have a point. We have a load of points that work for this. y minus t is equal to minus 1/3. So y minus 1 times z, which is now t. Okay, y is equal to t minus 1/3. And my final answer then is x, y is plus t minus 1/3. So I'm using this line, minus 1 minus t is equal to 2. So this is x, y, and z. X, y, z. X, y, I know, yeah. Z. We do have an x value.
We do?
Yeah, we get an x value. So the t's are going to cancel here, t minus t. So we get x is equal to
Minus
2 and
plus
a
30.
7 over 3, yes.
7 over 3, sorry.
7 over 3.
That makes more sense than writing 2 plus a third.
Yes.
Okay.
And so we sub it into an equation.
Well, that is the equation.
That is the equation?
That is the equation.
Oh.
Yeah, so it's a vector equation. So you can write it x, y, z if you want is equal to t if you want to put it in the order we usually like, and z is t. That's the vector. So it meets. So you would say it meets at the line. Meets at the line. The correct terminology when we get this system is called, and you probably know this, or I'm reminding you,
Sorry,
infinitely many solutions to that. Yeah.
X equals.
Oh yes, x does not equal t. Sorry, 7 over 3. Yeah. Second.
Hey, we at least know the coordinate of the x that it is. So that's
Yeah. Okay.
Is that coincidental?
No, that's they all meet at a line, and we just found that line.
No, I meant, is it like a coincidence?
the fact that x is a constant.
That's a coincidence. Yeah, it
Yeah, that is
won't always happen like
It
that.
just
Yeah.
happens.
So
Yeah.
it could all
Actually-
be based off t.
Yes. Usually, more than likely, it'll all be based off
And so,
t.
Wait, can we technically find out what t is then? This is a
No, you don't, because
No,
it's a
because it could be an infinite number of numbers.
any place along the line will be a solution. Yeah.
but it's, so they all meet at the x coordinate 7 over 3, but along the